of the relation. So we have the set containing these points, 3, 5, 3, 7, 8, 5, and 8, 7. Well, this particular relation is not a function because in order to be a function, you cannot have one x value that repeats, like this 3 and this 3, that repeat but go to different y values. The first 3 matches with a 5 as the y value. The second 3 matches with the 7, and that can't happen if it's going to be a function. Never mind the fact that the 8 repeats as well. But the thing is, if any one x value repeats and goes to 2 different y values, then it's not a function. So the thing to look for is, do any of the x values repeat, and make sure that if it repeats, it has to go to the exact same y value. And you're probably never really going to see any setup like that. So this one is not a function, but the domain consists of all the x values. It's a set. This symbol right here, these curly braces, always indicate a set. And so the domain is the set of x values. And so the braces are given to you. So inside the braces, you have to place all the values that represent the domain separated by commas. So that would be a 3 and an 8. Notice I did not write 3, 3, 8, 8. You do not repeat values when you're putting them in a set like this. So I've seen it many times where students repeated those, and it marks the answer's wrong because you're not supposed to repeat them. So even though the 3 appears 2 times and the 8 appears 2 times, you only write the 3 and the 8 once. And then same thing for the range. The range is the set of all y values. So in this case, we have a 5, a 7, a 5, and a 7. So we only write 5, 7 one time for the range. So 5, comma, 7. Those are the only values that appear in the range. All right. The second one asks the same question. Does the relation represent a function? Give the domain and the range. So let's look at the x values. Do any x values repeat? Well, we have a -1, I'm sorry, -8, +8, a -9, and a +3. Well, since none of the x values repeat, we can safely say that this is a function. The domain would be the set of all the x values. So that would be -8, 8, -9, and 3. And then the range would be the set of all y values. Okay, so here that would be -1, 3, -9, and 3, but we're only going to write the 3 one time. So that would be -1, 3, -9, and the order does not matter when you're entering these values into your set, but you must separate the values with commas. All right, let's see. Now, determine whether the following equation defines y as a function of x. Now, the thing that you're supposed to do is solve the equation for y, and then analyze the equation to see what happens when you plug in values of y. values of X. I don't know how everybody's teacher has taught this. Maybe some people have taught, a shortcut, or maybe there are some things that you can recognize. But at first glance, when you look at this, at this stage, you should be able to tell that this is going to be the graph of a parabola because there's a y and there's an x squared there. Because that x squared, this makes it a quadratic equation. And so this would be, if you were to graph this thing, this would be a parabola. And a parabola is a function. If it's opening upward or downward, it's a function. So that's the thing that you can determine just at a glance. But technically, you're supposed to take the equation and solve it for y. So here we have x squared plus y equals 169. If I subtract x squared from both sides, we get y equals negative x squared plus 169. So this would be a parabola that's open upside down. So it really would be a function. And the thing is, you're supposed to analyze what happens if you plug in a value for x. So for example, think about it. If you put in a 1 for x, you're only going to get one output for y. If you put a 1 in for x, let's say we have this negative in front and then 1 squared plus 169. You're on, where's my screen? Come on, screen, don't, I think my screen is about to stop sharing. Yeah, I knew that was going to happen. Give me a second. Technology, when it's good, it's good. Change the way I do this. Okay, give me a second. I'm gonna stop this share. I'm gonna stop. There's a different way to skin a cat. So share here. Okay, here we go. You should be able to see my screen now. So if we solve this or plug in a value of 1, how many y outputs are we going to get? We're only going to get one y output because this will simplify to negative 1 plus 169, and then that would be a 168 for y. But any value of x you put in there, whether it's 1, negative 1, 0, a million, 72,000, whatever you put in for x will produce only one output. And that's how we determine that it is, in fact, a function. If it produced two outputs, then we would say, no, it's not a function. But you can determine it however you were taught how to determine it. If you recognize that shape, that particular equation represents a function, then you're welcome to go ahead on and state that. So this one is a function. But if your teacher requires you to actually solve the equation to show that, you've done some actual work to determine that, then that's what you have to do. So this one is definitely a function. The next one, number 4, again, if you recognize that this x squared plus y squared equals 36 represents an equation for a circle, and you know that a circle is not a function, then you can simply state, no, this is not a function. But the technical reason is that when you solve it for y, if you have x squared plus y squared equals 36, and you solve for y, that means get the subtract x squared from both sides, and that will leave your y squared equals 36 minus x squared. And then this is the part where you show that it's really not a function, because when you take the square root of the left side, you have to take plus and minus the square root of the other side. And simplifying, we get y equals plus and minus the square root of 36 minus x squared. And what this shows is that that plus and minus literally is telling you that for any x value you put in there, there's going to be two y values, a positive version and a negative version. So if one x produces two y values, then it's not a function. And so that would be the algebraic way to show that this is not a function. Number 5 says to evaluate the piecewise function at the given values of the independent variable. We have two pieces for this function, 2x plus 3 if x is less than 0. And if x is greater than or equal to 0, we're going to use x plus 5 as the function. So looking at our values of x that are being given here, we have x equals, and the first one, we're going to plug in a -3, and then a 0, and then a 1. So for -3, we have to determine where -3 is as it relates to 0, because it states that if x is less than 0, we use the first equation. And indeed, -3 is less than 0. So for f of -3, we have to put the -3 into the top equation. So 2x plus 3, but where there's an x, I'm going to place a -3. And then simplify. So that means 2 times -3 is -6, and then plus 3 equals -3. So f of -3 equals -3. That means when I place a -3 in for x, I get a -3 out for y. Then for f of 0, the piecewise function says if x is greater than or equal to 0, right? Greater than right here or equal to 0, we use the second function, x plus 5. So we have 0 plus 5, which is simply equal to 5. So f of 0 equals 5. Then f of 1. 1 is greater than 0, so we're going to use the second piece again. So we'll replace x with 1, so that's a 1 plus 5, and that is just simply equal to 6. So f of 1 is 6. And again, there's an assignment in your My Math Lab where it will be similar to this, same types of problems, exact same types, but with different values. So you can go ahead and look at that. Now, I hate that this is so small, but at least I can pinch it out to make it bigger on my iPad. So we've got a problem here with 12 parts. This problem we have to do all sorts of things. So the first thing is to find the domain of this function. So the domain has to do with how far left the graph goes and how far right it goes in terms of x values. So looking at the graph, the arrows indicate that they're going forever and ever to the left. And on the right-hand side, it's not only going upward, but it's going outward forever. So the domain contains all real numbers. And we write that by saying the domain goes from negative infinity to positive infinity in interval notation. Always read the instructions. Type your answer in interval notation. The range, I'll have to pinch it out to kind of see what the numbers are. The range goes from the lowest y value on this graph to the highest. So let me see if I can, let me make the x and y axis a little bit more prominent. That's the y axis. That's the x axis. So the range goes from the lowest y value on this graph to the highest. So the lowest point on the graph is this point down here that I'm making red. And then the y value of that point is a -1. It's one space below the x-axis. So the y value is -1, and then the upper y value is going to be positive infinity, because this thing's, the lowest value is -1, highest value really is not a value because it's going up to positive infinity. You can't look at it and say, oh, it goes up to 24. Well, on the 24 is on the graph, but that's on the left side. Yeah, it stops on the left up at 24, but on the right side, it goes up forever. So our range will be from -1 all the way to infinity. But on that -1, we're going to place a bracket because the graph goes through that point at -1. So you must include it. And then on infinity, we always place a parenthesis. Okay, so starts at -1, goes to infinity. It has to be in that order, has to be from the lowest value to the highest value. That's the range. The x-intercepts, where the graph crosses the x-axis. All right, so the graph crosses the x-axis or touches the x-axis here and here. All right, that's 1, 2, 3, 4, and 6. It touches the x-axis at 4 and 6. Read whatever the instructions say. It says, what are the x-intercepts? Here you're given the left intercept of the function is 4. They're telling you what the left one is. You just have to tell what the right one is. And I think I said the right one was at 6. Here, they're not asking for an ordered pair. They just want the number. If they wanted an ordered pair, it would say right beneath the box, enter an ordered pair. So that is the right x-intercept. Then we want the y-intercept. Let's see, it crosses the y-axis at 24. It touches the y-axis, it crosses at 24. That's the y value where it crosses. So the y-intercept is 24. Over what interval is f increasing? So a lot of students get confused with this. What we want is the x values we want the x values over which the graph is going upward from left to right. Increasing means the graph is going upward from left to right. Decreasing means the graph is going downward from left to right, and constant means the graph is level or horizontal from left to right. It's constant. Constant meaning the y values are not changing. But for this one, I want to do constant first, just because it's constant over what interval? Well, if you look at the graph, everywhere from way, way, way out at infinity, negative infinity, from this point, from everywhere from negative infinity all the way to the y-axis, it's constant. But what we want is the x values for which that's true. We want the x values. So we're looking down here at the x-axis, and we're going to tell all the values up until 0. Those are the x values that represent the part of the function that is constant. So the x values that we want go from negative infinity all the way to 0, not to 24, but to 0, because that's the x value where it stops being constant. So the constant piece goes from negative infinity to 0. Parenthesis on negative infinity and a parenthesis on 0. Now, let me just say this. For all problems that relate to constant, increasing, a decreasing, you never use brackets. Only parentheses. Because these are what we call open intervals. Open intervals means they have parentheses. They're open intervals. People get this confused all the time. You don't put brackets. You may use brackets with domain and range, but not when it's talking about increasing, decreasing, or constant. Okay. And so we did constant. Then I want to do decreasing. So where is the graph decreasing? Well, the graph starts decreasing when x is 0, because I'm going to use a different color. It starts decreasing from 0, and then it stops decreasing right here. It stops decreasing at 5. 1, 2, 3, 4, 5. When x is 5, again, when x is 5, that's when this function stops decreasing. So it starts decreasing at 0. It stops decreasing at 5. And that's what we're going to place as our interval. It starts decreasing at 0, stops decreasing at 5 with parentheses on both ends of that interval. Then where is it increasing? Well, it starts increasing at 5 and then increases forevermore towards infinity. It's never going to stop increasing once it gets past 5. So it starts increasing at 5. It stops increasing. Well, it never stops increasing. It goes on increasing forever to infinity with parentheses. Any questions? Because some people have questions. I'm not going to, I can't entertain every single question, but if you got a question about this, ask it. The reason you don't the reason you don't use brackets, and this is an example I give my own students. If you're on a roller coaster, think about it. If you're on a roller coaster and the coaster is going up and up and up and up and up, and then it comes to a point where it feels like that roller coaster stops. It feels like it stops, and then it starts going down. Well, at the point where it stops, it's no longer increasing. It's not doing anything. It's just sitting there. It's not increasing and it's not decreasing at that point. Okay. So at that point, it's at a standstill. So you can't include it with decreasing and you can't include it with increasing. And so therefore you use parentheses and not brackets. Okay. Because at that point, it's not any of those things. All right. Then it says, what is the number at which f has a relative minimum? The number at which f, the function, has a relative minimum. All right. That means look at the lowest point on this graph. Let me erase all of my fine work here. Find the lowest point on the graph. And that's this point down here. Identify the x and y values for that point. Well, that is a 1, 2, 3, 4, 5. X is 5. Y is -1 at that point. What the question is, it says, what is the number at which the function f has a relative minimum? What they're asking for when they say at which, they're asking for the x value of that point. When you see the word at, that means give them the x value. When you see in the next piece of the problem where it says is, the minimum is the y value. So once you identify the x and y values, you can answer these questions. So it says, what is the number at which f has a relative minimum? Well, what's the x value of that point? 5. So the minimum happens at 5. But what is the minimum? What is the lowest y value? Well, that would be -1, the y value. So when you identify the point, you've really identified the number at which the minimum happens and what the minimum value actually is. Okay, the at goes with the x value, the is goes with the y value. Is, or sometimes it's are, if there are 2 of them. Then it says, what is f of -5? This means what is the y value when the x value is -5? So if you're looking on your graph, go find out, go from your origin to -5 in the x direction, and then go up or down to meet the graph, wherever the graph is, and then figure out what the y value is. So all this is saying is when x is -5, what is y? So I'm going to go to the graph. When x is -5. So what you want to do is grab your finger or your pencil or whatever and say, all right, I'm starting at the origin. This is the origin that I have highlighted here. And if I go left 5 spaces, 1, 2, 3, 4, 5, and then go up to touch the graph, well, the y value at that point is 24. So that's what we want. F of -5 is 24. What's the y value when the x value is -5? All right. Then K says, what are the x values where f of x equals 3? And then they tell you the leftmost x value of where f of x is 3 happens when x equals 3. So this is a little different now. They're asking you to find the x values. In the previous part, in part J, they gave you the x value and asked you to find the y value. This time they're giving you the y value and they're asking for the x values. And you got to realize what this says. It says, what are the x values where f of x equals 3? F of x simply means y. When y equals 3, what is x? Or what are the values of x? Well, let's go to the graph and see. When y is 3, we're going to go up the y-axis from 0. And then we're going to find where on the graph the y values are 3. So going upward from the origin, 1, 2, 3 spaces, and then go over to the graph and figure out what x value it is right here where y equals 3. So it's going to be 1, 2, 3 right here. And then keep going and you'll find another one over here where y equals 3. Okay, both of those happen where y equals 3 right here. Okay, so it's what now? 1, 2, 3, 4, 5, 6, 7. So 3 and 7. I think they give you one of them. It says the leftmost x value where f of x is 3 is when x is 3. So they gave you that one. What is the rightmost? Well, that one is going to be where x is 7. And is the function even or odd or neither? Well, an even function is a mirror reflection about the y-axis. It's symmetric about the y-axis. It looks the exact same on the right side of the y-axis as it does on the left side. This graph doesn't look like that. All right. A function that is odd will be symmetric about the origin, which means if you rotate it first over the y-axis and then over the x-axis, it would be the exact same graph. But you have to envision this. You got to use your sanctified imagination to envision this. If you rotate this graph over the y-axis and then over the x-axis, it's not going to be the exact same graph as it is here. So it's not odd. And in this case, this particular graph is neither. So that printed on the next page, it's neither even nor odd. All right, that took forever. All right, number 7, use the graph to find the following. The sign of the leading coefficient, the vertex of this parabola, the axis of symmetry, the intervals where f is increasing and where f is decreasing, the domain and the range. So what we know about a parabola that's upside down is that the leading coefficient or the coefficient of the square term must be negative. That's because it's upside down. The sign of the leading coefficient must be negative. The vertex of the parabola is where the parabola goes from increasing to decreasing or from decreasing to increasing. It's either the maximum point or the minimum point. So the vertex for this parabola is the point -2, 2. -2, 2. Type an ordered pair. The axis of symmetry is a vertical line that goes straight through the vertex. Vertical line. A vertical line, the equation for a vertical line always starts with x equals. And if I know that the vertex is at the point -2 and 2, okay, that's the point -2 and 2, the line going through the vertex is going through where x is -2. So once you find the vertex, you have really the value for your axis of symmetry. It's going to be the line x equals -2 because it's literally going through the x value where x is -2. So that's the equation. But you must read the instructions right below. It says type an equation using x as the variable. You can't just put -2. You have to put x equals -2 because that is the equation. Then the function is increasing for what interval? They're asking over what interval. So the function is increasing all the way from out here at -infinity until you get to -2. The function stops increasing when you get to x equals -2 at that point. It's increasing because from left to right, it's going upward. Don't worry about that downward arrow. Don't let the arrow fool you. The graph is going upward from left to right, upward from left to right, from -infinity all the way to -2. So from -infinity all the way to -2, it's increasing. Then it stops increasing and starts decreasing at -2 and decreases forever to infinity. So it decreases starting at -2 all the way to infinity with parentheses. Again, you're looking at the x values. What's the domain? Well, the domain for any parabola is going to be negative to positive infinity because unless there's some endpoints that stop it, but this is not stopping. This thing, you're looking at how wide it gets from left to right. And as it's going downward, it's also going outward. And if you can imagine, it's going outward forever. So it's going to encompass all x values, all real numbers. And the only way we can denote that is in interval notation from negative to positive infinity. The range, though, the range means the lowest y value to the highest y value. Well, when you think about, and you got to go from the lowest to up to the highest. So this graph goes down forever and ever. So there is no lowest value. The lowest thing that we can account for is -infinity. So it goes from -infinity up to this point. And what's the y value of that point? It is 2. So this graph has a range from -infinity to 2. All right, find the average rate of change. Average rate of change, the formula is going to be given to you. You have to find the f of x2 and the f of x1. They give you x2 and x1. So let's see what the function says. The function says we're going to look at x squared plus 2x, and we're going to see what happens to it as it goes from x sub 1 being 5 and x sub 2 being a 6. But you need to organize your work so you're not confused about what's going on. Some of the work I see sometimes is writing all over the page, and it looks like you're a right-handed person that's trying to write with your left hand. Make your work neat. Make your work organized so you can follow it, and so that whoever has to read your work can follow it. So the first thing you need to start solving this, not solving, but evaluating this average rate of change, look at the pieces that you need. You need to find f of x sub 2. That means take x sub 2, plug it into the function. So f of x2 means f of what value? Well, what is x2? X2 is 6, so I need to do f of 6. But what does that mean? That means take that and put that into the function. Put a 6 into the function. So that means 6 squared plus 2 times 6. Which simplifies to 36 plus 12 or 48. So f of x sub 2 is 48. So go ahead on and put this in your formula. If we know we need to write f of x2 minus f of x1, then go ahead on and put it over here. 48 minus something. Well, now we've got to find f of x sub 1. F of x sub 1, and when I say sub, it means subscript 1 equals f of, well, what is x sub 1? 5. So f of 5. So let's plug a 5 into the expression here. So that's a 5 squared plus 2 times 5, which is 25 plus 10 or 35. So f of x sub 1 is 35. So I'm going to now place the 35 into the formula where it asks for f of x sub 1. So that's a 35, 48 minus 35 over x2. But they already told you what x2 is. x2 is 6 minus x1, which is 5. But then if we simplify the numerator, let's see, 48 minus 35 is 13, I believe. But you have a 13 over 1, but we don't write 13 over 1. We just write 13. So the whole average rate of change simplifies to 13. Now, I am recording this. I'm trying to move through it because yesterday's recording went too long. It took forever for me to even download it. So I'm recording it. You can come back and look at it later. Find the average rate of change for the function x squared. So the same kind of problem, but the function is different. So f of x sub 2 minus f of x sub 1 over x2 minus x1. But this is a different function. So they give you x squared as the function. 4 is x sub 1, 36 is x sub 2. So what we need to find is f of x sub 2, because that's what's first in the function, means f of 36. But what is the function? Well, it's the square root. So we need to take the square root of 36 to get a 6. That's it. So f of x2 is 6. So this is 6 minus something. Well, let's see what it is. F of x sub 1 equals f of 4. But the function is the square root, so we're taking the square root of 4, which simplifies to 2. So f of x1 is 2. So I'm going to place that in the formula. I have f of x2 minus, now I need a 2, over x2, which is 36, minus x1, which is 4, So let's see what happens here. You might need to use your calculator to simplify your fraction if you don't remember how to simplify fractions. 6 minus 2 is 4. 36 minus 4 is 32. All right, so that reduces to, excuse me, 1/8. Notice it says simplify your answer. That means don't give them a decimal. They want a fraction. They want a simplified fraction. Okay? And if it's not simplified, it's not correct. So 1/8 or 1/8 would be the average rate of change there. All right. Now, if those of you who are going to be taking your test on My Math Lab, then you should be familiar with graphing these transformations on My Math Lab. Some people are going to be taking their exams on paper. So you have to know how to graph these things, based on what your teacher has explained to you. But if
Excuse
you
me.
know, yes.
So whenever you did the 4/32 and you said it simplifies to 1/8, isn't there a way, like I know when I put 4 divided by 32, I get a decimal. How can I make it into a fraction again? Isn't there like a
Yeah.
button on the calculator? You have
There's a fraction button. Hold on a second. Let me pull up my other.
the ABC, second
Yeah, the
ABC or
ABC
something?
button. It's the ABC button. You put 4 ABC 32 and then equal. You
Don't
see it?
don't press the second button.
Don't,
4
no,
ABC 32
and then
and
equals.
equal. Yep.
Now, the only issue, there's another one somewhere where you get an improper fraction. I think there's another problem where we get an improper fraction. So you need to know how to, when you put it in your calculator will give you a mixed number. So you have to use that same button to change it from a mixed number to a back to a fraction, but you have to press the second key. Let me just make up an example here, and let me get my other screen shared here. My other camera, I mean. And I'll go back to the iPad in a second. So if you got your calculator here, and let's say,
The other question I have is for when you get 6, like whenever you change the square root of 36 to 6, are
uh-huh,
we able to simplify that 6 anymore? Like saying like 2 times 3, or is 6 the
why,
lowest it can be?
why would you do that?
I
I
don't
mean, I
know.
mean, give me a reason.
But something wanted me to go ahead and simplify it more. So you don't simplify it
But
anymore?
how can you simplify a 6 though? It didn't say factor it. It didn't say write it in factored form.
Okay.
Six is
I
just an
know
integer.
sometimes like whenever you simplify it, how you put the number on the outside of the radical and then on the inside.
Yeah,
So
but 36 is a perfect square number. There is nothing left under the radical after you take the square root of
okay.
36. That's only if you have a piece of the number that has to remain under the radical, that you would have to keep it like that. Like if you had the square root, well, can y'all see my screen with my hand and stuff now?
Yes.
Yeah.
Yeah.
Yeah. So if you had now this is off topic now. So if you had the square root of 72, that's not the same as the square root of 36. 72 is not a perfect square number, but 72 contains quite a few perfect square numbers, but the biggest one is 32. I'm sorry, 36. 72 means 36 times 2 under the radical. And if you do that, then you take the square root of 6 out, I mean of 36 out of the radical as a 6. The square root of 36 is 6, but the 2 has to remain under the radical. But if you
Yes,
just have
that's
the
what I
square
meant.
root of,
Yep,
if you have the square root
that's
of
what I meant.
36, that's just 6. If you have the square root of 25, that's just 5. There's nothing left under the radical. Yeah, you're looking for extra work, baby. That We don't, there's nothing else to simplify. But what I was going to show you is if you had a number like, wait, let me think. No, I'm gonna wait. I'm gonna wait because there's an example that has a mixed number situation. I'm gonna show you how to do that later. All right, let me go back to my pad. Oh, this is not the, well, is this what we were doing? Wait a minute, I lost my darn page.
That's not it.
Here
We're
we
on
go.
number 9.
Yeah, here we go, because I still had my one up from yesterday. Okay, so that was the average rate of change. Good, so now we're gonna use transformations. And again, what I was saying is some people are gonna be given paper tests, so you have to do this however your instructor has told you to do it. But if you're using my math lab, you have to have the skill for how to do that as well. But I'm not gonna be able to go back and forth to my math lab to show you how to do this, but recognize the different transformations that exist, okay? And I'm reviewing, I'm not teaching this now. This is supposed to be a review. So you should all be familiar with this enough to be able to think this through right along with me here. So everything in your function, every number, every sign, everything means something. So number 10 is the absolute value function, which you should already know is the shape of a V. It's either going to be a V that's right side up or a V that's upside down, depending on whether there's a negative in front of the actual function and actual absolute value. So here, right here, there's a negative sign in front of this one. So that means a reflection over the x-axis, which in your mind should already tell you that your graph needs to be an upside down absolute value. Because if it's reflected over the x value, over the x-axis, that's what it means. This -4, this represents a change, a horizontal change or a horizontal shift from the origin, but it's a shift in the right direction, a horizontal shift right. And there are all kinds of little tricks that people teach for you to memorize that this is a horizontal shift to the right 4 spaces. Your brain looks at that x -4 and you think, oh, I should go left. I should go left because minus means go left. Well, inside the function, it does the opposite of what you think it is supposed to do. So x -4 means a horizontal shift, but it means a horizontal shift to the right, not to the left. The -3 here at the end, outside of the function, represents a vertical shift. But because the the vertical shift does just what it's supposed, what your mind wants it to do. So this -3 means a shift down 3 spaces. So then you go and you select all that apply. It's a horizontal shift 4 units to the right. So I'm going to check off E. It is a vertical shift 3 units down. So I'm going to check off F. It's a reflection about the x-axis. So I'm going to check off D. And the way my math lab grades this is if you check off the wrong things, they're going to take points off. And if you don't check off all the right things, they're going to take points off. And if you graph it incorrectly, you will have points taken off. So every little thing you click matters. All right. So this thing has a vertical shift, a horizontal shift, and a reflection. All right. So the original function, parent function for this thing, for absolute value, looks like this is the parent function with no shifts no kind of adjustments. But if this whole thing had to be shifted four spaces to the right, and 3 spaces down, and reflected, flipped over, 1, 2, 3, 4, 1, 2, 3, it would look like this blue graph. It would look like the blue one. So look, we want to do the horizontal shift, 1, 2, 3, 4, then go down 3 spaces, 1, 2, 3, and then graph, and then turn it upside down, and then place your points to get your graph done there. That's the absolute
Excuse
value.
me. When we do
Mhm.
this on the test and we have to put it on the graph, so I know where we have to put the first plot would be right there where you have that blue one. Where would our second one go?
Wait, say it again.
So
When you
whenever
do,
we're doing it like on the computer,
uh-huh,
like I know that I know how to find the place where you just put the blue mark under the 4. I see how you did the horizontal shift. You went 4 spaces to the right and then you went 3 units down.
uh-huh.
So I see how you did that. Where would I put my second plot at?
Well, that's what you have to you have to figure that out. So the way I teach, and again, I'm not able to teach this. This is supposed to be a review, but what I teach my students is that there are 3 key points. I call them key points. The vertex for the parent function, for the parent function.
Sometimes, like in the
Wait,
homework, I'm
wait.
sorry, in the midterm review that I did, they had these little gray boxes at the bottom where it said you could put, like, you could type in the vertical shift
Yeah,
and the
I know,
horizontal
but the
shift.
absolute value doesn't have that. All of them have
Okay.
that except the absolute value. Okay, so where you just tell it there, like if you for the parabola, you're gonna click the parabola tool, and you drop the parabola on your screen. It's gonna put the parent function, and then you at the bottom, you have to tell it, okay, there's a vertical shift, there's a horizontal shift, there's a, whatever. Yeah, but the absolute value doesn't do that. You have to know at least 2 points on this graph. And one of the points is going to be the vertex. So if you know your original function, the original parent standard function has these 3 points on it, plus millions of others, 0, 0, 1, 1, and -1, 1. Notice that's what the points are that I put on this red graph. I put those points, 0, 0, 1, 1, -1, 1. Why did I do that? Because if I know those 3 points, I can use those points to figure out other points. So another thing is just like uh, parabolas have a vertex, absolute value functions have a vertex. The vertex for the parent function is 0, 0. But looking at the function here, the vertex for this thing is going to be 4, -3. Why is it 4, -3? The vertex is 4, -3. The new vertex for the new function. Well, how do I know that? Because it's moving 4 spaces to the right and 3 spaces down, and that's where I get this point from. So look at my vertex from the 0, 0 point, I'm highlighting with my little pointer here, from 0, 0, my vertex is 4 spaces over and 3 spaces down. But just imagine if you flip your parent function over, you're still going to have 2 points, a point here and a point there, because those match up with the point here and the point there. They're going to be 1 space down and 1 space out. So on my math lab, what they're going to say is the first thing you want to do is plot your vertex. The vertex is going to be 4, -3. Then they're going to say, give me another point. Well, you just take your mouse and you mouse over this point right here, down here, because that's just where it's going to be. As if it was right side up, you shouldn't have a problem figuring out the 2 points, but flipping it over, your 2 points are now down here, one space away from the vertex and one space down. Just imagine if I flip this blue one up and then shifted it up 3 spaces and then to the left 4 spaces, it would match up exactly with the red one. So you have to figure out what the vertex is. The vertex you can figure out from the actual equation. The vertex is going to be whatever this number is. If it's minus, if it says -4, the vertex is going to be 4 and -3.
I know what
All
the
right.
vertex is. For some reason, I thought that we had to go, like to find the second plot, I thought we had to go 4 places more to the right and then go down -3 units to
No,
put the second plot.
no. Everything shifts at the same time. So the whole thing, every point is going through the same change. What happens? Forget about the vertex. Look at this other point. Look at this. Let me make it another color. Let me make this point I'm making green. That point is going 1, 2, 3, 4. 1, 2, 3. But it's got to flip. Wait, that's right. Wait. 1, 2, 3, 4. 1, 2, 3. But it's got to flip over. Did I do this right? 1, 2, 3, -4, 3, down 3. One, two, wait, am I counting right? 1, 2, 3, 4, and then down 3. Yeah, and then it flips over. Okay, so it's not an additional flip. I'm really going beyond my time here. So just go practice. That's all I can tell you. Practice with the absolute
Okay,
value because that is the
that's
most
fine. We can
challenging
move
one.
on. I
Yeah.
understand. Thank you.
The other ones are easier because once you put the parent function in there, you just tell it what to do. And I don't know why they have it set up like that, but you got to find a point. You got to find a second point. All right. So for these, I'm not going to graph these. We'll just talk about what the transformations are. This one says f of x equals x squared. You're going to use the transformation of that one to plot x squared minus 4. Well, that one's really easy because it's the same function, just shifted down 4 spaces. Okay, so that's the parent function. And it says what transformation is needed. Well, the graph should be shifted 4 units down. So again, when you go and plot it, I'll do this one is quick. If you grab the parabola tool in my math lab and graph it, they're going to give you the parent function. But down at the bottom on the right-hand side, you're going to have the little box where you tell it that to shift it down 4 units. And then it's going to shift it down 4 units. And that's that. But if you're graphing on paper, you have to literally move every point on the graph down 4 spaces. You have to do that and then draw your new graph. All right, this one is an x squared. It has 2 transformations. It has a shift, horizontal shift to the right, and it has a reflection over the x-axis. But it's still a parabola, x squared. All right, I'm doing this very quickly. So this is a shift to the right and a reflection. So the whole thing shifts 3 spaces to the right and then over the x-axis. But again, in my math lab, you're going to tell it what to do. So it should be shifted horizontally to the right 3 and reflected about the x. So that's going to be, I think, D down here. This one has a transformation horizontal, shift left, And this one is a shift down, but it's still the
Wait, I
parabola.
thought that it shifts right because it's negative.
It is. My bad. Thank you. Thank you. Did I say right on the first one? Yeah. Okay. My brain. Right. You're right. Don't do as I do. Do as I say. Yeah, it is a right shift. All right, and then shift down. So we've got the original parabola. And let's see, this one shifts right. How many spaces? 5 spaces right and 5 spaces up. So let's see, 1, 2, 3, 4, 5. And then up 1, 2, 3, 4, 5. So this one will look
You got shift
like,
down.
like that. Down? Oh, God. That's because I'm tired. I'm sorry. Up. Jeez. I'm telling you, that session took me 2 hours and something yesterday. All right, I'm sorry. Right and up. All right. Find the domain of the function. Now, y'all, this one should be a no-brainer because this is a polynomial function. This one should not require much thought from you. This particular function it's not a rational function, meaning it's not a fraction, and it's not a radical function. It's not a radical function. It's a polynomial function. And polynomial functions all have the same domain. The domain is from infinity to positive infinity because there's no way to write anything and to make, see, my screen's about to freeze up again. All right. There's no domain restrictions. There's no value of x that you can put in there that's going to make this expression an undefined expression. There's no such thing. So if you know what a polynomial is, the domain is always negative to positive infinity. All right.
You said because there's no rational and no radical and no fraction. What was the other thing? It's no, you have to check for no fraction.
Wait a minute. Let me think what I said, baby. Let me think what I said. You know, I can't even get my thoughts together. What is a rational function? Do you know rational means a fraction? A rational function looks like number 15. Doesn't number 15 look like a fraction? Look at it.
Yes.
Okay. Is number 14, does number 14 look like that?
No.
Okay, so it's not a rational function. Is it a radical like number 16?
No.
No. So it's not a radical function. Those are the only 2 types of functions that have domain restrictions right now that we've learned about. There are going to be 1 or 2 more later on. But if it's not a rational function and it's not a radical function, it's a polynomial function, and all polynomial functions have the domain of negative infinity to positive infinity. But when you do have a rational function like number 15, when there are x's in the denominator, okay, if you've got variables in the denominator, then you're going to have problems with domain issues. So what we do for rational functions is set the denominator equal to 0 to find out what values have to be restricted from the domain. What do I mean? Well, the denominator can never equal 0 if it's going to produce a function that's a real values, real number values. But we have to figure out what values of x will make it 0 so we can exclude them from the domain. And the only way to do that is to set the denominator equal to 0, figure out what value is going to make it 0, and then say, hey, you can't put those numbers in the domain. So this requires factoring. So we factor the x squared minus 8x minus 20 into our two factors, two linear factors, x. Let's see, if I need two numbers that multiply to negative 20, but add to negative 8, I believe that's a negative 10 and a positive 2. So we have x minus 10 times x plus 2. That's factored. And then we take each one of those factors and set them equal to 0 to figure out what the excluded values are going to be. So we have x minus 10 equals 0. This is how you solve a quadratic equation by factoring. This is something we cover in 030. And if you in 030, you should have seen this. If you're not in 030 and you're just taking 130, this is something you should have seen in prior classes. So x minus 10 equals 0, or x plus 2 equals 0. Then we solve for x. So we add 10 to both sides on the first equation. So that means x is 10. And then we subtract 2 for the other one to get x equals negative 2. These two values are the restricted values for that function. That means they cannot be included in the domain. The domain is every number in the whole world except for these two. But you have to put that in interval notation. So there are two values that we're excluding. So think about a number line from negative infinity all the way to positive infinity. And you have to take out the number negative 2. You have to take out the number negative 10. And then indicate that in interval notation. And it looks like this. I don't have room in the box to write it, but it means that the domain goes from negative infinity until you get to negative 2. And then you use the union symbol to indicate that there's a gap there. It's skipping over negative 2. Then it's going to pick up on the other side of negative 2 and go all the way to 10. But we can't include 10. So we put parentheses and then a union, because now we've got to skip over 10, then pick up 10 on the other side and then go all the way to infinity. So you have two values that you are excluding. So then you need to have two union symbols to indicate that those are the values that you are not including, that you're skipping over those. That little union symbol means there's a gap there. And the gap is where negative
Excuse me.
2 happens and where 10 happens.
Is there a reason why we do negative 2 first before we do the 10?
Yeah, because the numbers have to be in order from left to right on a number line.
Okay.
And if you put it any other order, it's wrong. Thanks for the question, because lots of people get that wrong. It has to look like your number line. You're starting at the smaller numbers, moving along as the same way you would on your number line. Absolutely. So with a rational function, you set the denominator equal to 0, because what you're trying to find is what's going to make the denominator equal to 0 so I can take those values out. Well, for a radical function, you set it up slightly differently, because now you have to think about what gives a rational function with the square root. The blues. Well, that's when you try to make the radicand, the value or the expression under the radical is called the radicand, R-A-D-I-C-A-N-D. And the radicand cannot be negative. You can't take the square root of a negative number or a negative expression and come up with a real number. You come up with imaginary numbers, but we're not thinking about imaginary numbers right now. We're thinking about what input can I put in here and still get a real number out. So if the radicand cannot be negative, that means it can be positive and it can be 0. The radicand can be 0 or positive. And the way you do that is you take the radicand, 2x minus 2, and you tell it, hey, this is what you can be. You can be positive, which means greater than 0, or you can be equal to 0. So we set the radicand greater than or equal to 0. And then we solve to find out what values of x meet that criteria. So to solve an inequality, we do it the same way we do an equation, except if we have to divide by a negative or multiply. But right here, all we have to do is add 2 to each side. Then we get 2x is greater than or equal to 2. And then divide by 2 on both sides to get x is greater than or equal to 1. So that's the beginning of your answer. All values of x that are greater than or equal to 1 can go into this function and give you out a 0 or a positive number. You can take the square root of 0 and you can take the square root of something positive, but you cannot take square root of something negative and get out a real number. So how do we write this in interval notation? Well, the interval notation for x is greater than or equal to 1 looks just like a bracket, a 1, comma, infinity, parenthesis. Greater than or equal to 1 means you're starting at 1, including 1, and going to infinity. All right, so the bracket must be there. Any values that don't meet that criteria will produce a radicand that's negative. So you have to limit that. So what functions have domain restrictions? Rational functions and radical functions, or square root functions, I should most specifically, square root functions. All right, so now we're going to do some algebra of these functions. We're going to add two functions together, subtract them, multiply them, and divide them. And that's all you do. Add them together, subtract them, divide, multiply them, or divide them. But with the division, you do have to find the domain. If there's a domain problem, you have to find it. So it says we have f, a function f, and a function g. F says 5x plus 9. G is x plus 5. The first piece says we want f plus g. So guess what you put between the two functions? Plus sign. So we go 5x plus 9 plus x plus 5. And this is going to be f plus g. And then we simplify, combine like terms. So that's going to be 5x plus x is 6x. 9 plus 5 is 14. So that's what f plus g is, 6x plus 14. The function that we just created, the 6x plus 14. The 6x plus 14 is this, let me do yellow. Is this a polynomial function? 6x plus 14.
Yes.
Yes, it's a polynomial function. So then what would be the domain of this function? If I
Negative.
told you
Negative
just
infinity to positive infinity.
exactly. So the domain is, you're going to choose the one that lets you put your answer in interval notation, 8. The domain of this function is from negative to positive infinity because it's a polynomial. All right. Then we're going to do f minus g. The only thing different with a subtraction problem is you have to remember that you're subtracting the entire second function. So you got to put it in parentheses. So we have f minus g is going to be f, which is 5x plus 9, minus the whole expression for g, which is x plus 5. If you don't put it in parentheses, you're probably not going to get this right because you're not going to know to change the sign of everything that comes after that. So simplifying, we have 5x plus 9. Then everything after inside the parentheses must change signs. That's what that minus means. So what was x becomes negative x. What was a 5 becomes a negative 5. And then you combine the like terms. So now we have 5x minus x, which is 4x, and then 9 minus 5, I believe that's going to be a plus 4. So f minus g is 4x plus 4. But again, the domain for this function is going to be negative to positive infinity because this 4x plus 4 is a polynomial as well. So in interval notation, I'm going to check off B. It's going to be from negative to positive infinity. Let me see something here. For those of you who joined after the first few minutes, I have put in the chat a link to a form where I want you to sign in. Just put your name and what do I ask you for there? I ask you for your name and your teacher's name and your email address. And at the bottom, it gives you my YouTube channel where I'm going to post this video. There's another one that I did yesterday. I'll put today's date on the one that I'm doing today. The one that I did yesterday is already up there. So, and at the end of the submission, when you click submit, it will take you to a page where you can download this specific form. My students and my evening class already have this. But other students are not going to have this form, so you can download it and go back and watch the video with it if you want to. But you can get that once you submit the little form. Okay, this is not for any credit or anything. This is just a way to make you make this form available and the video available. So I just put it in the chat again. All right, F times G. Well, what's F? F is 5x plus 9. But because I'm multiplying two binomials, G is x plus 5. So to multiply two binomials, we use our FOIL or distributive property. So we multiply 5x times x, that's a 5x squared. And 5x times 5 is a 25x. Then 9 times x is 9x. And then 9 times 5 is 45. And we can combine the like terms. We have 5x squared, 25x plus 9x is 34x, and then plus 45. That's what F times G is. 5x squared plus 34x plus 45. So but once again, for the domain, because this, what we just created, this function is a polynomial. So this one will have a domain from negative to positive infinity as well. But then when we get to f divided by g, so now we're going to be dividing. So f is 5x plus 9, dividing it by x plus 5, because that's what g is. Well, right there, that is the simplified answer. You can't simplify that anymore. So that is what you would type in the box. 5x plus 9 over x plus 5. And no, somebody's itching to try to cancel this x down here with this x up here. You cannot do that. Okay, it's not an x and an x. It's a 5x plus 9. That's a whole entity by itself. And an x plus 5. Okay, you cannot cancel when you have different terms like that separated by addition and subtraction. So this is as simplified as it can get. But now, because this is a rational function, this is not a polynomial, this is a rational function, so we have a domain problem. And the domain problem with the rational function is always with the denominator. So we set the denominator equal to 0 to figure out what values must be restricted. So we set x plus 5 equal to 0, then we solve x minus, we subtract 5 to get x equals negative 5. So what this means is negative 5 is the restricted value that you cannot put into this function, because if you do put it into the function, it will make the denominator equal 0. So we have to restrict this value from our domain. Any other number in the world is a good number to put into this function, except for negative 5. So how do we exclude the number from interval notation? Well, by using the union symbol. So the domain is going to be an interval notation. So we check off B, and then it's going to look like negative infinity all the way to negative 5, but we have to skip over the 5. So I'm going to use a union, I'm sorry, the negative 5, use a union, pick up negative 5 on the other side and go to infinity. So that's the domain of that function. The reason we had a domain problem is because it was a rational function with a variable in the denominator. All right, now this one is asking for some compositions that F circle G and G circle F. That means we're composing one function on another, or we're placing one function inside of the other function. So we have two functions, f of x equals x plus 1, and g of x equals 5x plus 1. The first piece, part A, says, we're going to do this piece right here. Find f composed on g. And it's this notation. Sometimes they'll write it like this, f of g of x, like that. So the function that you're going to place inside of the other function is always the one that's closest to the x in our notation here. So what function is closest to the x? Well, that would be g. G is the inner function that we're going to place inside of the function f, everywhere there's an x. So let's see what we have. Everything inside of g, which is 5x plus 1, we're going to take that and replace it into f, where there's an x. So where there's an x, I'm not going to put x. I'm going to put 5x plus 1. And then plus 1. Okay, I'm gonna put it in parentheses. You can see where I input the G, the function G, 5x plus 1 replaces the x in the function f. Now we simplify this. So we just drop the parentheses, 5x plus 1 plus another 1 is 5x plus 2. And that's f composed on to G. That's it. Right, now we're going the other way with it, with G composed on to F. So all of F now will be substituted into G where there's an X. Okay, so now we need to write out G. So G says, I'm taking 5 times something, but I need to put a parenthesis for that something because I got to put a whole expression in there, plus 1. The G of X does 2 things. It multiplies something times 5, and then it adds 1. But what is it going to multiply times 5? Well, the X plus 1 from F, function F. Then we have to distribute the 5 to get 5X plus 5, and then bring down the plus 1. And combine the 5 and the 1. So we get a 5X plus 6. So that's G composed on to F. 5X plus 6. So now that you found F composed on G and G composed on F, now they want you to evaluate those 2 composite functions. So I will highlight what we have over here. 5X plus 2 is our F composed on G. 5X plus 6 is G composed on to F. But now they want you to evaluate each one of those at -1. So it just means plug a -1 in there. So maybe I can separate. Okay, so we're going to replace now X with -1. So F composed on G of -1 means I'm going to replace X with -1. 5 times -1, and then plus 2. So it's -5 plus 2, which simplifies to -3. If my math is correct, -3. So F composed on G, evaluated at -1, is -3. Then the other one, we're going to replace that one with that X with a -1 as well. So G composed on F of -1 is 5 times -1 plus 6 now. So this is a -5 plus 6, which simplifies to 1. So G composed on F of -1 is 1. So we found 2 composite functions, and then we evaluated those functions at a specific value of X. All right. This one, number 19, says for f of x equals the square root of x, f of x is the square root of x. G of x is x plus 4. So they say find f composed on G. So f composed on G of x means G is going to become the inner function. So we're going to replace x with the square root now, instead of square root of x, we're going to have the square root of whatever g is, x plus 4. And that's all there is for that part A, the square root of x plus 4. But what's the domain of the composite function? Well, you have to consider the domain first of the inner function. Notice that the inner function g is a polynomial, x plus 4. G doesn't have any domain restrictions because it's a polynomial. But once I put g into the square root, the new function does have restrictions. The composite function has restrictions because it's a radical function with a variable under there. So for radical functions, to find out what the domain is, we take the radicand, x plus 4, and we say it must be greater than or equal to 0. And then we solve that inequality. Why must it be greater than or equal to 0? Because that means it must be positive, or equal to 0 because it cannot be negative. So we're trying to figure out what values will make it positive or make it 0. And so we solve this by subtracting 4. So that gives us x is greater than or equal to negative 4. Greater than or equal to negative 4, which means on the interval, you're going to be starting at negative 4 and going to infinity. But because it says greater than or equal to, it will be a bracket on negative 4 and a parenthesis on infinity. So that would be the domain from negative 4 to infinity. And what that means is you can put any value in this range, in this interval, into that function and get out either a positive number or a 0. All right. The function number 20, function x cubed minus 4, is a one-to-one function. When it tells you that it's one-to-one, that means it definitely has an inverse. And so they're saying now find an equation for the inverse. So the way you do that is you start off with what you're given. You're given f of x equals x cubed minus 4. You replace the f of x with y. Okay, then you interchange the x and the y. So where there was an x, you place a y. Where there was a y, you place an x. So interchange x and y. Then you take that equation and solve it for y. That means get the y by itself. So in order to solve for y, I'm going to start here. I'm going to add 4 to both sides. I'm changing colors when I start solving for y. So add 4 to both sides. So the left side now is x plus 4. The right side is y cubed. But I don't want y cubed. I want y. So that means I need to take the cube root of the y cubed. But if I take the cube root of y cubed, I have to take the cube root of the whole other side. That's the x plus 4. Has to be under the radical. And the cube root means you put a little 3 in the index. Not the square root, but the cube root. Okay, and so what the cube does is the cube root, this index 3 and this exponent 3, they undo each other. So what we end up with is a y equals the cube root of x plus 4. In this case, the x plus 4, both of them have to be under the radical. So we've solved for y, but now we need to recognize that this is not really y. This is the inverse of the function. So we change y to f inverse. It's not f to the negative 1. So we say y or f inverse equals this cube root of x plus 4. So, and that's for all values of x. There are no restrictions for this one because this is not a square root function. This is not a rational function. It's a square root, a cube root. And cube roots don't have any domain restrictions. So when they say for all x, that's what that means. There are no domain restrictions. So this would be the first answer, and we would put our cube root of x plus 4. It doesn't have any domain restrictions. All right, 21. This is a one-to-one function. Find f inverse. So we start out, change f of x to y. So y equals 3x plus 2. Then we interchange the x and the y. So x equals 3y plus 2. Then we solve this equation for y. Solve means get the y by itself. So I will subtract 2 from both sides. So that gives me x minus 2 equals 3y. But I don't want 3y, I want y. So I must divide both sides by 3. So we now have y equals x minus 2 all over 3. And then we change y to f inverse. So f inverse equals x minus 2 over 3. Now, this one is a rational function, but it doesn't have any variables in the denominator. That's the key for dealing with domain problems. For rational functions, if it doesn't have a variable in the denominator at all, then it doesn't have any domain restrictions. So this is going to be true for all real numbers. There are no restrictions. So this is going to be part C for all values of x. So it's going to be x minus 2 all over 3 for all values of x that because the denominator doesn't have any variables. Distance between 2 points, all you have to do is identify your x1 and y1. I always take a minute to do that so I don't get my values confused. And I'm going to call the first point x1, y1. The second one x2, y2. It doesn't matter which one you call point 1 or point 2 because the distance between them doesn't change based on the name you give it, but it helps to give you some organization so you can remember what your y2, y1, x2, and x1 are.
Excuse
So
me.
yes,
Did you say that we're going to have the formulas provided for us for these on the test?
yes. Say thank you.
Okay,
'Cause
thank you.
I didn't get them when I was in school. We had no formula sheets. We had to know all the formulas.
So are they
So
going to be like on the first page, like
it
where, I mean, the
depends
first
on
slide,
how your
probably?
teacher has it set up. They may give you
Okay.
a formula sheet. They may put it in the problem, in the first problem of the if you're taking it online, it's going to be in the exam. If you're taking it on paper, you're going to get it on paper. But even if you're taking it online, whoever's in on campus online, they'll give you a formula sheet. But if you're taking it online at your own house on responders, it's inside of the exam in the first question. So you can always refer to it. All the formulas for the whole course are there. So no, don't thank me, thank the department, because again, I had to memorize all of this back in the dark ages. And so anyway, we have x1, y1, x2, y2. So all we do is plug in the values, but having the formula sheet doesn't help you if you don't know what to do with them. Now, so you have to master how to go ahead and use these functions. So inside of the radical, we know we're going to be adding, subtracting two things and squaring that, and then subtracting two other things and squaring that. So it's a matter of placing the values in here. So x2 minus x1. So my x2 is 5 minus my x1 is 2. So I'm going to place those in there. Then y2 is 8 minus y1 is 5. Okay, so step by step, I have the square root now of 3 squared plus 3 squared. Because 5 minus 2 is 3. 8 minus 5 is 3. We're squaring both of them. So that means the square root of 9 plus 9. But I need to combine that to get the square root of 18. And this is where the formula won't help you. You have to know that 18 is not a perfect square number, but it can be simplified. The radical can be simplified. How do I know that? Because I know that 18 has a factor that is a perfect square number. That's a 9. Okay, so you take the square root of 18, and if you still have to rewrite it, everybody hasn't, some people have advanced beyond having to write this down, but if you need to write it down, write it down. 18 can be written as 9 times 2. So that 9 times 2 goes under the radical, and then you take the square root of 9, you take the 9 out of the radical and put it in front, but it comes out not as a 9, but as a 3, because that's the square root of 9. But it's 3 times the square root of 2. Okay? Square root of 2 is not an integer, so you can't take it out. So that is when they say, simplify your answer, type an exact answer using radicals as needed. Do not put the square root of 18, because yes, that's a radical, but that's not simplified. You don't want that one. You want the 3 rad 2 is the exact answer using radicals. Then it says, express the distance rounded to 2 decimal places. This is when you want to put it in your calculator. You want to take the square root in the calculator of 18. And how do you do that? Well, you press the second key, and then you press the x squared key, and then you put your 18 in there, and then you press the equal button. So second, x squared, 18 equals. So you should get, and they want it rounded to 2 decimal places as needed. So you got to know how to round to 2 decimal places. So when I put that in, I got 4. Come on now. 4.2426, blah, blah, blah. But I only want it rounded to 2 decimal places. So that's going to be 4.24. If the number after the 4 had been a 5 instead of a 2, then we would have rounded it to 4.25. But 4.24 is the second part of this answer. Now we find the midpoint. Midpoint is easy. You add up the x values divided by 2, add up the y values and divide them by 2. So identify your x and your y. So x1, y1, x2, y2. So the midpoint, and it doesn't matter what order you add them in. You can do x1 plus x2 over 2, and then y1 plus y2 over 2. So we're combining the x terms, combining the y terms, right? And then divide each of those by 2. So what is my x1? 2. What is my x2? -7. Put it all over 2. I'm going to come back and simplify that. That's going to be the x value of the midpoint. X value. This is not an equation. This is a point that we're trying to identify, an x and a y value. Then y1 is -10. Y2, -6. So it's really -10 minus 6 over 2. So with the first one, we end up with a -5/2, -5 over 2. And the second one, the y value is going to be -16 over 2. But I can simplify that one a little more. The -5/2, leave that alone. It's reduced. It's already a fraction. You do not want to make that into a mixed number. Don't put that in your calculator as 5 divided by 2 or -5 divided by 2. Just simplify your answer. Simplify your fraction if it ends up being a fraction, but do not make it into a mixed number. We don't use mixed numbers at all in this course. Okay, you always want to leave it as a fraction, even if it's an improper fraction, meaning even if the numerator is bigger than the denominator or equal to the denominator. So, and then this -16 over 2 is -8. So that's the midpoint. -5/2, comma, -8, ordered pair. Number 24 is center. They're giving you the center and the radius of a circle. Write the standard form of the equation for a circle. So the standard equation, x minus h squared plus y minus k quantity squared equals the radius squared. The h and the k represent the center. So to write this in standard form, you plug in the values. They give you h is 6 and k is 8. So x minus 6 quantity squared plus y minus 8 quantity squared equals whatever the radius is, 3 squared. However, you don't want to leave it like that. I've seen problems where you don't want to leave it as 3 squared. You want to go ahead and write that as a 9. So the official answer is x minus 6 quantity squared plus y minus 8 quantity squared equals 9. That's the standard form. All right. Then this one, 25, says complete the square and then write the given equation in standard form, then give the center. So to complete the square, you have to complete the square on the x's and the y's. So we start off, this is given in, this is called general form. Okay. We need to write in standard form, and you can't just do that without completing the square. So we get our x terms, x squared minus 2x. And to complete the square requires you to add something. So I always like to use a little placeholder for what I'm adding. Plus, we get the y squared minus 8y plus whatever I'm going to add to complete the square. The -19, the constant always goes over to the other side. But when -19 goes to the other side of the equation, it becomes +19. But I always too, and you don't have to do this, but I always make my same two placeholders on both sides of the equal, because whatever you add on the left, you have to add on the right. So how do we complete the square? Take half of the coefficient of this middle term here, x term, and then square it. Half of 2 is 1. 1 squared is 1. So I'm adding a 1 to both sides. Then take half of this 8, or even negative 8. It's going to be a 4, and square it. It's going to be a 16. So we're adding 16 to both sides. So simplifying both sides now, well, factoring both sides, of the left side, we get x minus 1 squared plus y minus 4 squared equals 36. So that's the equation. X minus 1 squared plus y minus 4 squared equals 36. The center of the circle is 1, 4, that point, 1 comma 4. The radius is not 36, it's the square root of 36, or just 6. You can't tell what the center and radius are when it's in general form, but you can tell what they are when it's in standard form. All right. So looking at this, I think after we solve the system of 3 equations and look at a couple of even, odd, or neither things, I'm calling it quits. So solve the system by substitution. This is a 2-equation system. Substitution says solve one of your equations for one of the variables. Well, in this case, one of the equations is already solved for y. So what this means is everywhere there's a y, we can replace it with 4x minus 4 in this system. In this system, every y can be replaced with the 4x minus 4. So that's what I'm going to do. In the top equation, replace the y with 4x plus 4. So rewriting the top equation, we get x plus 2 times something, whatever I'm going to replace y with, equals 10. But I'm replacing y with 4x minus 4. So that means I need to distribute that 2 to the 4x and the minus 4. So 2 times 4x is 8x. 2 times negative 4 is negative 8, and that equals 10. Then we can combine our like terms to get 9x minus 8 equals 10. Then I'll running out of space. I'll bring this up here. 9x minus 8 equals 10. And then add 8 to both sides. So 9x equals 18. Divide both sides by 9. So x equals 2. So we have a value for our x coordinate. Remember, we're looking for an ordered pair, a point where these two lines are intersecting. So we have the x value. Now we take that x value and substitute it back into either one of the equations. Okay, I'm going to substitute it into equation 1. So I'm going to write out y equals 4 times x, but x is 2, minus 4. So that means 8 minus 4, or simply 4, y equals 4. So the answer is the point. Notice where it says the solution set is, and they open up these braces. You have to type an ordered pair inside of there. You have to put your parentheses and put your 2 comma 4. They only intersect at their one point. Number 27, solve the system by addition. So you can choose which variable you want to eliminate. But the first thing you have to do is line up your x values and y values on the left side of your equation and your constants on the other. That's how you start off with the addition method. Then you decide if you want to eliminate the x values or the y value first, because the addition method is also known as the elimination method. So we're going to eliminate one of the variables. So this is up to your discretion. You have to choose which variable you want to eliminate, and you have to choose what you're going to multiply by to get this done. You're trying to create opposites. So I'm looking at looking at the 2x and 3x. They're not opposites of each other. And looking at the negative 3y and the positive 2y, they're not opposites of each other, but they are opposite signs. So I would personally choose to try to eliminate the y values, because I am looking at a negative 3y and a positive 2y and thinking I could multiply the first equation by something to get a negative 6y. The least common multiple for 3 and 2 is 6. So if I could make that negative 3y somehow a negative 6y, and then make the 2y into a positive 6y, I can go ahead on and eliminate these two y values. So that's what I'm going to do. I'm going to multiply the first equation by 2. So I will end up with a negative 6y in that equation. I will multiply the second equation by 3 to allow me to have a positive 6y. Now you could choose to eliminate your x's by multiplying one by something negative and one by something positive. There are a number of different ways to do this correctly. So my way is not the only right way. It's all about how you see it. There's plenty wrong ways to do it, but there are a few right ways to do it. So I'm going to multiply everything in the top equation by 2. So that gives me 2 times 2x, 4x, 2 times negative 3y, negative 6y equals 2 times 4 is 8. Then I'm going to distribute the 3, the second equation. So that gives me 3 times 3x is 9x, plus 6y equals 3 times negative 7, negative 21. Okay, so now I have 2 new equations, but they're equivalent to the old equations because I multiplied them by the same value. So then we add these things straight up and down, and the y terms become 0, right? Because they are opposites of each other and they have been eliminated. So what's left is 9x plus 4x, which is 13x. And on the right, we have a negative 13, if I'm not, if,
That's right.
negative 13. All right, so then if we solve this, we get 13x equals negative 13. If we divide by 13, we get x equals negative 1. So one thing I know, my x value of the ordered pair is negative 1. So I'm going to go down here and put this negative 1, but we need to find the y value. So we go back and we insert a negative 1 into one of the original functions, equations, one of the original ones, either the first one or the second one. I'm going to choose the first equation and put 2x minus 3y, but x is negative 1, minus 3y equals 4. And now I have to solve for y. We already know what x is. We're replacing x with negative 1 so we can find y. So 2 times negative 1 is negative 2. Then minus 3y equals 4. Then we add 2 to both sides. We have negative 3y equals 6. Then divide by negative 3. So y is negative 2. So our ordered pair is going to be -1, comma, -2 with an parentheses around them. All right. Then we have this three equation system. What I need is a separate page. If you're trying to work it out on a page here, you're gonna have to use more space. So the equation looks like this. We have 8x minus, the system looks like this, 8x minus y plus 2z equals -1. That's the first equation. That's equation 1. I like to label them. Equation 2 is x plus 2y minus z equals -9. Equation 3, 2x plus 2y minus 3z equals -14. So it's a system of three equations. You got to be organized and you got to have a plan for what you're doing. So what you do is you look at your three equations, label them, choose two equations to eliminate one variable. Now I'm looking at, this is the same way I looked at it yesterday. I'm looking at the y values and I'm thinking about eliminating y because I'm looking at first equation and the second equation. If I could multiply the first equation by a +2, then that would end up giving me a -2y. In the second equation, I have a +2y. And then if I choose equation 1 and equation 2, I can eliminate the y. Then if I choose equation 1 and 3, I could do the same thing to eliminate the y. So that's what I'm fixing to do. I'm going to choose equation 1 and watch. I'm going to put a circle around my little 1 here and put times 2. I'm going to multiply that times 2. So equation 1 is being multiplied times a 2. And so my new resulting equation is going to be 2 times 8x is 16x. 2 times -y is -2y. 2 times 2z is 4z. And then 2 times -1 is -2. I multiply that equation by 2. My equation 2, I don't have to change at all. I'm going to keep it as x plus 2y minus z equals -9. So then I have opposites for the y terms. Okay, -2y and +2y. So when I add these values, columns straight up and down, the y terms are going to go away. And I will have 16x plus x, which is 17x, and then plus 3z is going to equal -11. Now, some people might call this equation I just found, you might call it equation 4. I always use alphabets for this second go around. I call that equation A. Then I'm going to use two different equations to eliminate y again. This time I'm going to use equations 1 and 3. First time I used 1 and 2. Now I'm going to use 1 and 3. But I'm still going to multiply equation 1 times the 2 to give me a negative 2y to cancel with the positive 2y. That's in equation 3. So I already know what this is going to be. This is going to be 16x minus 2y plus 4z equals negative 2. And then equation 3 is 2x plus 2y minus 3z equals negative 14. I'm going to add straight up and down. The y terms go away. And what remains is 16x plus 2x. That's an 18x. Then a plus 1. Yeah, plain old z. 1z or just z equals negative 16. All right, so that's equation what I call B. Notice A and B now. A and B are equations that only have two variables. So we have two variables and two equations. So we've reduced the system from 3 equations and 3 variables to 2 equations and 2 variables. And now we're going to use A and B to figure out what we can do. So I'm going to write A as 17x plus 3z equals negative 11. And equation B is 18x plus z equals negative 16. So again, I'm not interested in fooling with a 17 and 18 to try to make them opposites of each other with the 17x and 18x. I'm more interested in trying to eliminate the z, because all I have to do is multiply the bottom equation, equation B, by a negative 3. So negative 3, because I want that to become a negative 3z. So equation B multiplied by a negative 3 becomes 18 times 3. So negative 54x minus 3z equals 3 times negative 16. Negative 3 times negative 16 is a positive 48. And then I'll just bring over equation 1 as it is. 17x plus 3z equals negative 11. So now I have the z's with opposite coefficients. So then I can zero those out and then bring down the 17x and the minus 54x. So when we add those two, 17 minus 54, that's a negative 37x equals now positive 37. Negative 11 plus 48, positive 37. So then if I divide by negative 37, we get x equals negative 1. So what we're looking for with 3 variables and 3 equations, we're looking for something called an ordered triple. Okay, the ordered, not the ordered pair, but an ordered triple will be inside of parentheses 3 numbers separated by comma. So we're looking for an x, y, and a z value. Now that we found negative 1 for x, we've found x, we have to back up into one of these A or B equations. We have to back it up into one of those equations, place that x value in there, and then solve for z. You can't go all the way to the top equations yet. You don't have enough information. You have to backtrack through all the equations that you've created. So we're going to backtrack and place our value for x into one of these equations. I'm going to replace it into equation B. So B says 18 times X plus Z equals negative 16. However, X is negative 1. Okay, X is negative 1. So we can now solve for Z. So 18 times negative 1 is negative 18 plus Z equals negative 16. And then if I subtract 18 from both sides, add 18 to both sides, my bad, add 18 to both sides, we end up with Z equals 2. So what do we have? We have now a value for X, a value for Z. We need to take these two values so we can go back and find Y. Since Y was the first variable I eliminated, it's going to be the last one that we find on our way back. So choose one of the equations and plug in the values of X and Z. I'm going to choose equation 2. Equation 2 says X plus Y, 2Y minus Z equals negative 9. So I'm going to replace X with negative 1, Z with 2, and solve for Y. All right, so I'm solving for Y now. So I have a 2Y minus 3. I'm combining the negative 1 and the negative 2 equals negative 9. Then I can add 3 to both sides. So 2Y is now equal to negative 6. But then if I divide both sides by 2, we get Y equals negative 3. So now I have a value for Y. So the ordered pair is going to be, the ordered triple is going to be 1 in the X place, negative 3 in the Y place,
Negative one.
and 2. Negative 1, thank you. Negative 1 in the X, negative 3 in the Y, and 2 in the Z. So that would be the answer that you write on, where is it? Right here, negative 1, comma, negative 3, comma, 2. All right.
Can you go back to the problem again so I can copy down number 2?
Number 2, the last equation.
The last equation you just did. I was still
Yeah.
copying it down.
You see it on the screen what you need?
Yes, ma'am.
Okay. You know when you got it.
Okay, I have it.
All right. All right, so determine whether the function for 29 is even, odd, or neither. Then determine whether the function's graph is symmetric with respect to the y-axis. Well, origin or neither. If the function is even means it is symmetric about the origin. I'm sorry, about the y-axis. Symmetric about y-axis. Odd means symmetric about the origin. And if it's not symmetric about either of those things, then it's neither. Neither means it's not symmetric about anything, or not symmetric about any of these two things. Okay, but technically what you're supposed to do to find out whether a function is even or odd is replace the f of x with f of negative x and compare the terms. So I don't know what your instructor is looking for, but this is how you determine. You say f of negative x. You plug in negative x and simplify the function. So everywhere there's an x in the function that's given, the function here is x cubed plus 6x. So that means everywhere there's an x, I'm going to put a negative x. So negative x in parentheses cubed plus 6 times a parentheses with the negative x. Always use parentheses when you're putting these values in, because otherwise you're going to get something wrong. Plug the value, replace every variable with a parenthesis, and then put your number or expression in there, negative x. So when we simplify this, negative x raised to the third power, any negative number raised to a third power is going to end up negative, because you have a negative times a negative times another negative. So this will simplify to negative x cubed. And then 6 times negative x is negative 6x. So it's not just about doing that. You have to analyze the situation. You look at the function that you just created and compare that to the original function, comparing the signs of each term. Look at the sign in the first function, the given function f of x cubed is positive, and the 6x is positive. In my new function, x cubed is negative, and the 6x is negative. So both signs of every term have changed. So when that happens, when all the signs change, we say that this is an odd function. If they change from positive to negative, negative to positive, but all of the terms have to change signs. It's odd, which means it's symmetric about the origin. Okay. If we look at 30 and do the same thing, g of negative x, I'm going to replace x with negative x and simplify. Well, when I compare, when I simplify, I'm sorry, I am looking at a negative x raised to a 6th power. Well, that's a negative raised to an even power. So that means anything raised to an even power is going to end up being a positive number, because you have a negative times a negative. That's a positive. You got another negative times a negative, and that's a positive, and then another negative times negative. That's what x negative x to the 6 means. So that's going to end up positive x to the 6, but then minus x. Compare the signs. In the original function, x to the 6 is positive. The second function, x to the 6 is positive. In the original function, x is positive, but in the second function, x is negative. So when some signs change and some signs don't, we say the function is neither even nor odd. Neither, so it's not symmetric, because all of the signs didn't change and they all did not remain the same. Some changed and some didn't. That means neither. So you have to investigate the signs. Then 31, this one says same thing, determine whether it's even, odd, or neither. This is going to be the last one I do because the rest of them are similar to other things that we've done on this page. All right. Replace x with negative x. So we have the function h. So we're going to do h of negative x equals 4 times negative x to the 4th plus negative x to the 8th. Well, we have 4 times what? Well, again, negative x to the 4th power is going to become positive x to the 4th. And then plus negative x to the 8th power is going to be positive x to the 8th. So then when we compare our signs from the original function to the new function, they all have remained the same. The signs for both terms have remained the same. They haven't changed. So this function is even, which means it is symmetric about the y-axis. And I'm gonna stop here. So but the rest of this on here is similar to what we've already done, and you get to practice. So this whole worksheet is basically a replica of what you have in your midterm review assignment in my math lab. So you can use this as reference. Your problems are not going to be exactly the same, but you can use this as a reference for when you're working your review assignment out, which you can do multiple times. Now, I don't know when everybody is scheduled to take their midterms, but you know, you have opportunities for review. So I'm going to stop here so I can get this thing. It's got to first finish loading to the cloud, the Zoom cloud. And that's going to take a while. And then I got to download it to my computer. And then I got to upload it to YouTube. But if you check the chat again, you can fill out that form. Click on the chat in the chat and click on that form, fill it out. And then if you want the video, you can go to my YouTube channel later on this afternoon and find it, and you can download the worksheet. So I just put it in the chat again. Okay. So I'm gonna stop because I've been talking a long time. You all have a great rest of your day. I'll be doing another one at 6:30. So I mean it's gonna be the same worksheet.